Hello and good afternoon, CSI 157 Section 841 students at Anne Arundel Community College for the Spring 2014 semester. Today's PacketTracer tutorial is going to build on our previous PacketTracer tutorial, which was 9.1.4.6, in which we had a couple of routers, some switches, and a few hosts. This PacketTracer tutorial, which is 9.1.4.7, is going to expand upon that, and we now are presented with 4 routers, 4 switches, and 4 PCs. Okay, so let's get into this activity. As you can see here, we have our addressing table, which you can fill out at your leisure, and our objectives are going to be to design an IP addressing scheme, and then also to assign IP addresses to network devices and verify connectivity. So in the scenario, it says you're given a network address of 172.31.1.0/24 to subnet and provide the IP addressing for the network shown in the topology. The required host addresses for each WAN and LAN link are labeled in the topology. And so the first thing, part 1, design an IP addressing scheme. So it's asking us to subnet the 172.31.1.0/24 based on the maximum number of hosts required by the largest subnet. So simply taking a look over here, you can see that this link here is requiring 2 hosts, same thing across the board for each of the router-to-router links or point-to-point links. This subnet is 10 hosts, 8 hosts, 14 hosts, and 12 hosts. And so what's interesting is if you come down to the subnet table, you can see that they actually get you started with your first subnet. And so it looks like we've got 14 usable host IP addresses. And so we're going to need to figure out what subnet they're using, what that subnet mask is going to be, and how we would apply those subnets to the devices in the fashion that's going to be required to get 100% on this PacketTracer activity. So as you can see, this is the subnet that we're dealing with, and we need to divide it down. And it looks like we're going to have a maximum of 14 hosts in the subnet. And so this is one way that we can attack this problem, is to go ahead and take a look at the last octet, right? 3, 4, 5, 6, 7, 8. And we know that the equation for the maximum number of usable host addresses is 2 to the n minus 2, where n are the number of host bits. So in the scenario where we have 2 to the 7, or I apologize, where we have 2 to the 8, right? So we've got 8 host bits here. We would have a total of 256, and then we want to subtract 2, and that's going to be 254 usable IPs. So 2 to the 7 is 128, and when we subtract 2 from that, we would have 126 usable IPs. 2 to the 6 is going to be 64, but when we subtract 2, and again, just to review, the 2 that you see being subtracted here, right? The first address will be the network ID, right? And the second address is going to be your broadcast address. So that's why we pull those out, because these are not assignable to hosts. So back to our equation. So 2 to the 6 is 64 minus 2 is 62. 2 to the 5 is equal to 32 minus 2, which is equal to 30. 2 to the 4 is 16 minus 2 is equal to 14. And right here, we have found the subnet that we're looking for to finish out. 2 to the 3 is equal to 8 minus 2 is 6 usable host IPs. 2 to the 2 is equal to 4 minus 2 is equal to 2 usable host IPs. And so this would be a /30. That's a /29. Our IP subnet CIDR is going to be a /28. This would be a /27. And this was from the previous PacketTracer activity where we used a /27. This is a /26. This would be a /25. And that one is going to be a /24, or the default class C. All right, so we're very interested in this one right here. a /28. And so a /28 is going to equal, and let's take a look here, 3, 4, 5, 6, 7, 8. /28 means we've borrowed 25, 26, 27, 28. So we're borrowing half of the host bits. I'll draw a little line down here. We're borrowing half of the host bits and we're turning these into network bits, right? And so this is actually going to create 2 to the 4. So this would create 16 subnets, and then each of those subnets could have 2 to the 4 minus 2, or up to 14 hosts. And so then the value of this, when we do our subnet mask configuration on the router interfaces, is 255.255.255, and then the value of these 4-bit positions added together. So this is 128, whoops, bad 8 there, 128, 64, 32, and 16. And so we already know that a /27, which is these 3 bits here, is 224. And so 16 added to 24 would be .240, right? So when we do our subnet masking, you're going to see us using the 255.255.255.240 for our subnet mask when we configure our interfaces. Okay, so let's come back over to the PacketTracer activity, and we're going to come down here, and it says assign subnet 1 to the R1 LAN interface. So I'm going to flip the page. We're going to go to a new page here, and we're going to try to start with a clean slate. And so we'll come up here. So subnet number 0. They like to start with subnet 0 for R1. Right, and we know that we're dealing with a 172.31.1.0, right? And we've seen this before. So, and I'm going to do it this way. So that I'll put a little squiggly here. So the first usable IP is going to be .1 up to .14, and then the broadcast address would be .15. And so that, or those, are the addresses that we have for subnet 0. For subnet number 1, we've got 172.31.1.16, and remember, that's our block size, or the increment size that we use between each of the subnets. So the first IP will be .17. The last host assignable IP is going to be dot. And again, keeping in mind that we've got 16, so we know this is going to be 31, so it would be .30. And then keep this going here, and it'd be .31 is our broadcast. So I'll label this here. So this is bcast for broadcast, and this is our network ID. Okay, and these are the host addresses here. Trying to make this a little cleaner from the last example we did. Okay. So then we've got subnet number 2, which is going to be 172.31.1. And it's not going to be 16, it's going to be 32. And again, remember, it's going up by 16, right? Or we know that we're going to add 1 to this and give us the .32. So with that in mind, if I were to do this, I really don't even need to complete that addressing table to figure out what subnet number 3 will be. 172.16, whoops, little dot there, .16.1 dot, and we know it's going up by 16, so 32 plus 16 is 48. So back up to subnet number 2. So the first host assignable IP is .33. The last host assignable IP is going to be whoops, I was hoping to avoid that, so .46, because the broadcast is .47. And then we go to 48, so then it's 49 all the way up to, and again, if you were to add 16 over here, you know that this is going to be .63, and this would be .62. And so then we'll go ahead and draw our line here. So subnet number 4 is 172.16.1 dot, and if we add 16 to 48, we get 64. So I'll bring this down here, continue this on. And so it's going to be .65 all the way up to, and if we add 16 to this guy, it's going to give us 79, and that's our broadcast address for subnet number 4, which means our last usable IP is .78. All right, and then again, one more, last one here, I believe. Subnet, okay, we've got to go all the way to subnet number 6. So subnet number 5 is going to be 172.16.1, and if we add 16 to that, we get 80. And so then it actually looks like 88, so that's a 080. So the first usable IP is .81. And if we were to add 16 to this, we're going to get 95. And the last usable IP is going to be .94. Oops. All right, so we've got one left here. And this is going to be subnet number 6. So 172.16, whoops, .16. I'm sorry, I just changed it. So it's 31. This is actually 31. I'm used to doing the 172.16. So 31, 172.31. So .1. If I add 16 to 80, I'm going to get 96. First usable IP would be .97. And if I were to add 16 to 95, I get 111. Because if I add 16 to 96, I'm going to get 112. So this is going to come up to 110. My broadcast would be 111. And you can confirm that by doing 95 plus 16 is 1. Add your 1, 10, 11, right? Okay, so here are our 6 subnets. Again, I apologize. I got carried away with the most common 172, which is 172.16, but these are 172.31 in the second octet. Okay, so we've done all 6 of the subnets that we're going to be using. And so then let's come on over here. So document your addressing, right? Assign the first usable IP address to the routers for each LAN interface. Use the following method to assign the WAN link IPs. For the WAN link between R1 and R2, assign the first usable IP to R1 and then the last usable IP to R2. Assign the second usable IP address to the switches and assign the last usable IP to the host. And this is where I overlooked on the last PacketTracer activity. We were assigning the second assignable address and not the last. So we're going to get that this time. All right, so here we go. There's 4 steps to configure connectivity. So let's configure IP addressing on R1 and R2 LAN interfaces. So we'll scroll down here just a little bit. There we go. So R1 and R2 LAN interfaces, which will be these guys here. So if I pull that guy up, let's go ahead and take a look at what we've got here. We're in user exec mode. We'll transition to privilege exec, go into global config mode, and I want to go into interface. The LAN interface is gig 00, gigabit Ethernet 0/0. So we're going to bring the interface up right away, right? And then we're going to go ahead and we're going to assign the IP address. And so for the R1 LAN, it says assign subnet 0 to the R1 LAN. So I'm going to go ahead and do IP address 172.31.1, and remember, for the LAN IPs, we're going to assign the first usable IP. So 172.31.1.1, right? If you come back over here, you can see that these are the usable host IPs for subnet 0, which is what we're dealing with here. And now we need to know, what is our subnet mask? And so again, that's where it becomes important that we remember, and I'll page back here. From the previous page, you can see that we figured that out, and that should be .240, right? .240. All right, so back over to our subnet setup here. Okay, so that's going to be our IP address, and I can go ahead and put a description on here, and I'll just simply put LAN interface. Oops. LAN interface. All right. So that interface has been configured, and it should be up. I'm going to go ahead and type end to remove myself from interface configuration mode back to privilege exec mode, where I'm going to go ahead and I'm going to save my configuration. Okay, so if I do a show IP interfaces brief, oops, you can see that the gig 00 interface is configured and it's in an up and up status. And I've saved my configuration, so I'll close that down. So now it says configure IP addressing on R1 and R2 LAN interfaces. So we've done R1, and now let's step over, and the second part of that task is going to be R2. So we're going to pull the CLI up for R2. We're in user exec, transition to privilege exec, into global config mode, and then interface config mode. And we'll go ahead and bring our interface up right away. And for R2, it's key to remember here, it says assign subnet 1 to the R2 LAN. And so here's subnet number 1, right? So our first usable IP, so these are all of our usable IPs for subnet number 1. And the first usable IP is going to be the .17 address. So it's going to be 172.1.17. And then we know our subnet mask is a /28, 255.255.255.240. And again, we can add a description on here and just say LAN interface. So this is in theory. In practice, you want to make sure that you have a very descriptive entry there, so that if you ever have to troubleshoot, or had to go back and maybe it had been a year or two, you'd have a very good idea as to why or what you configured on that interface and why. Okay, so the LAN interface for R2 has been configured. So we're going to exit interface configuration mode to privilege exec mode, where we're going to save our config, and then we'll do a show IP interfaces brief. All right, so the gig 00 interface is configured, and it's in an up and up status. So let's go ahead and close this window. So we've done step 1, which is configure IP addressing on the R1 and R2 LAN interfaces. Now we're going to do step 2, which is configure IP addressing on switch 3, including the default gateway. And so coming back up here to the scheme, right, assign the second usable IP address to the switch. So here's switch 3, which is part of router 3's LAN interface, right? It's connected to router 3. So if we come up here, assign subnet 2 to the R3 LAN. And so all of the addresses that we're dealing with are here in subnet 2. And so this will be critical, right? This is probably the trickiest part, because you've got to understand that router 3, right, per the instructions here, is using subnet 2. Then you need to make sure that you've got subnet 2's IP addresses correct, and then you can go ahead and make that configuration change. So let's do that now. So we're going to jump onto switch number 3, and we'll come over here, and so we're going to go from user exec to privilege exec into global config mode, and then into interface config mode, because we're going to configure interface VLAN 1. And that's the default interface. So the first thing I'll do is bring that interface up. And then I'm going to go ahead, I'm going to type in IP address. And now remember, so for the switches, it's the second usable IP. Looking at subnet 2 here, the second usable IP would be .34. Because that IP .33, I can guarantee, will be the interface of the router R3, the gig 00 interface right there. So we're going to use .34. So IP address 172.31.1.34, and we know our subnet mask is 255.255.255.240. I'll just add a description in here, VLAN 1 interface. Okay, so the VLAN 1 interface has been set. If I want to go up just one level from interface configuration mode to global config, and this is where I'm going to set my, IP default gateway. And again, a reminder, very quick one, because I went over this in 9146, is that this IP default gateway command is needed for traffic that's being generated by the switch, not traffic that's transiting the switch from the hosts and the servers or the wireless network communications. This is for traffic that's being generated by the switch. So when I ping, when I trace route, that's where this command becomes important, specifically when I try to go to a different subnet and I need to know my default gateway. So we know that our default gateway address will be 172.31.1.33. Again, based off the addressing scheme, that first address of the subnet, which is right here, .33, would be assigned to that gig 00 interface on router 3. Okay, and so then we go 255, 255, 255, 240. Right? Oh, I'm sorry. I apologize. Interface configuration mode there for me. Okay, so it's IP default gateway, and then just simply the address. So 172.31.1.33. Okay, so we've configured switch 3, including the default gateway, and so we've got that. So let's exit from global config mode, or let's go end global config mode, back to privilege exec mode, where we're going to go ahead and save our configuration. So if I do a show IP interfaces brief, we've got all kinds of interfaces configured here, and there's VLAN 1, right? And we're in an up and up state, so we're looking good. Okay, let's close that down. We've got lots of green lights, which is good. So configure IP addressing on PC4, including the default gateway. And so again, this one's a tricky one as well. So subnet 3 gets assigned to the R4 LAN, right? So we have to know that subnet 3, which is over here, these are going to be our usable host IPs, right? So the first one's going to be .49, which we are going to know is assigned to the gig 00 interface on router 4. We know that the switch 4 IP address is going to use the second usable IP, and per instruction D here in our addressing scheme, assign the last usable IP address to the hosts. And so what is my last usable IP? .62, and that's in subnet 3. So I'll come over here to the host, PC4. So we'll pull that up. We'll go, oh, whoops, sorry. Config tab will be locked. Desktop tab will not. All right, so we're going to do a static IP address assignment of 172.31.1. And again, the last assignable IP, which is .62. As you would expect, since it's a 172 address, PacketTracer, at least PacketTracer, this version is going to automatically give us the default subnet mask setting for a Class B address, but we know that we're using a Class C subnet applied to a Class B address. And then our default gateway should be the first usable IP address in this range, which we saw right here is .49 for subnet number 3. So we'll do 1.49. Okay, and so PC4 has been configured. All right, the next step is going to be to verify connectivity. And so again, you can only verify connectivity from router 1, router 2, switch 3, and PC4. However, you should be able to ping every IP address listed in the addressing table. So let's check our results and see how we're doing here. All right, so we're at 100%, right? 30 out of 30, right? We've completed all 13 tasks. So theoretically, we should be able to test connectivity and it should work. Whoops. Okay, so we're going to look at our IP address configuration. We're good there. All right, so let's ping some different addresses. So I'm going to ping 172.31.1.1 and see if I can ping all the way over to the subnet 0. And let me pull this down a little bit here. So subnet 0 is on the R1 LAN. There we go. So subnet 0 is the gig 00 interface on router 1. Let me see if I can ping the host. And to ping the host, right, that would be PC1 would be the last usable IP, which should be 172.31.1.14. And again, I'm pinging devices on this segment right here, on this LAN segment right there. So I can ping the switch, I can ping the PC1. I'm sorry, I can ping PC1 and the gig 00 interface on router 1. Let's try to ping switch 1, which would be the second usable IP, which should be 172.31.1.2. And so let's take a look. We should get a timeout, maybe 2, and then we should have some success. All right, there we go. So from PC4, I'm going to go ahead and do the same thing for router 2's LAN segment. And again, that's going to be subnet 1, And so the first address would be .17, and that's the gig 00 interface on router 2. So I can ping there, no problems. Can I ping the switch number 2, which is the second usable IP, which should be 172.31.1.18. As we would expect, we've got the first attempt is going to time out, and then we should have success, and we do. And then let's try the host PC2, which if it's in subnet number 1, the last usable IP would be .30. And so let's try that out. And as we would expect, we get a timeout, but then it comes back. We have no problems at all. All right, and then R4, finally, we're going to go ahead and test our LAN 3 segment here. So let's go ahead and ping for subnet number 2, which is for the R3 LAN. There's our IPs here from .33 to .46. So let's ping .33, which is the gig 00 interface on router 3. 34 should be switch number 3, because that's the second usable IP address on that subnet. So that should have been assigned to switch number 3. We're going to get a couple timeouts here, and then we should have success. We do. And then PC3 is the last assignable IP, and that should be .46. All right. It's going to time out for us here, and then we should be good to go, and we are. Okay, fantastic. So from PC4, we have full connectivity across to all the different subnets. Subnet 0, which is assigned to router 1, subnet 1 assigned to router 2, subnet 2 assigned to router 3. So we could also check connectivity from routers 1 and 2, but we've already come through routers 1 and 2 to check other connectivity. Finally, we could check from switch number 3, and this would be important to make sure that our default gateway command is functioning like we would expect. So let's try 172.31.1.1, and we've got success over there. How about the switch number 2? That works. What about the host that's on that subnet, .14? And that's good. So now let's try the next subnet over, which would be .17. That's the gig 00 interface on router 2. .18 is switch number 2's IP address, and the PC2 is going to be .30, and that works great. So now let's try subnet 3, because we're on subnet 2, so we'll try subnet 3, which is PC4. So .49 is the gig 00 interface on R4. I'm also going to try .50, which is going to be the switch 4 IP address. And again, had to populate the ARP cache, and then we're good to go. And then PC4, which we've also configured, which would be .62, and we can ping through, and it works great. Okay, so we have our subnetting example over here for a /28 or a .240 subnet mask. We configured all of the devices that were required here and came up with an IP addressing scheme. And in fact, our IP addressing scheme created 16 individual subnets, of which we demoed 6 over here. We walked through the calculation for 6 of them. But it would have been, had we continued to go, it would have been all the way up to 16 subnets. And each subnet would be able to accommodate 14 host IP addresses. All right, this has been PacketTracer Activity 9.1.4.7. I hope that this has helped you out this week, and I will see everybody on Tuesday evening. Enjoy the rest of your weekend.